Today we have with us Erwin Lares, and he is part of Duke's research cyber infrastructure and is working as a consultant. So I'm actually going to turn it right over to him to get started, introduce himself a little bit more, dive into his work.
Thank you so much. Hello, everyone. I hope you had a good lunch. I did. I had a great table partner. My name is Erwin Lares, and I am part of a small department within the CTO office called Research Cyber Infrastructure. And we have a group of a portfolio of services that target researchers on campus, and we offer them a variety of services that go around storage, a tool called Electronic Lab Notebook, the one I lead, the data science platform, and we are also interface researchers with all major cloud providers. And I'm here today to tell you about a project that I started a few years ago. There's a lot of text, and I don't plan to cover the text, but to tell you the story is, I come from the social sciences, and we're not super adept at using technology. And so the idea was like, how can we facilitate a let's call it a normal researcher to access the computer services of CHTC. So that's how the whole thing started. I did my PhD here in UW, and I worked on phonetics and syntax, and I started working using R, and that's what I mainly use. It's what my home. And so what I want to show you today is what happened and how you can grab an analysis that you put into an R Markdown. I use Quada, but basically the same thing, and how you can grab that analysis and send it to CHTC with minimal fuss. I'm working out of a render document, but I have R in the backend. So what I was hoping to do is go through the process, talked about the obstacles and the lessons learned and whatnot, show you the code, discuss it. But if you want to see it running, we can attempt to do that, and hopefully it will not croak on me. So there's a couple of what I do want. Is this big enough? It's not big enough, right?
The text enlarges.
So what I do want to see is tell you the premises that I have. So I'm running out of some assumptions. And the assumption is that you're a researcher and you use notebooks. And if you don't, this is a plug for them. It's a great way to put your prose and your code together, and they're easy to version control. So they're a wonderful way to make reproducibility easier. And so your analysis is living inside a quarter document. That's one of the assumptions. The package dependencies are managed with a package called RM, and it's working correctly. Sometimes RM is a little bit picky, but when it works great, it creates this thing called a log file. That is basically a JSON file that tells, okay, we're using R version so, and these are all the packages that it does a listing of all the packages and all the dependencies that your thing needs. So it's good for reproducibility. You need to be able to log into CHTC. And if you have an ID, you can. You just need to request one account. You have Podman installed in your machine. If you're not familiar, Podman is a branch of, it's an alternative to Docker. You have to have an ID to access those resources. You have to have a GitLab account, and if you have an ID, you can request them. And you have to have a repo associated with your analysis. And inside the repo, you turn on the registry, the container registry. And for what I'm going to show you here, I'm going to assume that my analysis is called analysis.qmd, and my data is data.csv. But we'll see where it goes. And I have more. So that, okay, so out of analysis, the QMD is going to strip out the code, the part that you want to run at CHTC, and it's going to call it analysis.r. CHTC requires you to have two associated files to run two jobs there. One is a submit file, and we're going to call it analysis.sub, and one is a executable file, analysis.sh. The good news is that none of those you have to worry about. If you have one analysis of QMD, everything else is going to be derived from that for you. The only thing that you do have to do, and I'm working on a way to do remote submission, is you have to log in and actually run the job. And so let me stop for a second and ask if you have any questions, or what questions do you have? Nope. All right. And it's not as you, in case someone does in the chat.
Roadmap.
All right. So this is my roadmap. So I start with my analysis inside a markdown or a quarter document. I'm going to strip the code and turn it into an R script. And out of that, there's something that's going to determine what the R version is. And it's going to locate the log file. Out of that, this pipeline is going to create a Docker file. It's going to build the image. And it's going to log into registry.do.risk.edu, our GitLab instance. It's going to push that image to the registry. It's going to create the submit file, the executable file. It's going to copy all those created files to submit node at CHTC. You have to log in and run counter submit on your file. And then this ends by retrieving the results back into your laptop. And so the first part of that is to strip the code. And there is a wonderful function that I didn't know existed 6 months ago out of the native package that does exactly that. And so you can have all your great water file with all your pros and all your charts, but if you want the R code, this will get it for you. And I would like to take the time to talk a little bit about that documentation equals 1. There are 3 levels if you go 2, 1, and 0. If you go 0, it's just the code. If you do 1, it saves your comments. And if you do 2, it saves all your pros as comments. So it's kind of like the inverse of R Markdown. So you run that. And this was, in my head, someone was like, oh, how do I do this? And so I have some extra explanation and description in case you're not familiar with containers. But by show of hands, are you all familiar with containers? So we can skip this part. Is there anyone who wants to talk a little bit about containers? No, good. I mean, either way is good. So I'm gonna stick out, but if you go to the GitLab repo that they share with you, you can find that and you can read on your own. So far, I had an analysis inside my quarter document, and I had a way to capture the package dependencies that are needed to reproduce this analysis. So that's so far what I have done. The next step that I want to do is create the Docker file. And the Docker file is, because you're all familiar with, it is a text file that have the instructions to bake that image. And the only thing that I didn't know, I discovered doing this, is that there's this great R version that captures like, oh, I'm doing R version X. So you run that, it returns that, and with that, you can build the Docker file. There's one bit of code that I was particularly proud of. I'll show you. So this is what the Docker file looks like. So it grabs the R version. You have my CHTC on my so I should get rid of that. And what I did was like, oh, how do I build this? And then I realized that it's very templated. So what I need to do is just verbatim, just write what I need and just bring in from the code the pieces that are different for every job. And there's a function called glue that is great. In glue, similar to the Linux glue, you can put it in between quotations. And if you want something that is a variable, that is dynamic, you put it in curly brackets. So what this line here does, from Rocket and the Rocket project, our version, and what this does is that it grabs, it grabbed that R version and pastes the value there for the major and minor version of R. And so you grab what you need and you make sure that it was working on your computer. Now it will work here. Questions? No. And then this is a verbatim line. This is copying that log file into the container. This is copying the library. And then I run into an interesting problem is that I only have two levels of quotations. You have single quotations and double quotations. And it's like, oh, shoot, how am I gonna solve this? And I realized that that part doesn't change. So I set it up as a text file on the side, and then I imported it back into it. So I got around the quotation problems that way. So, and then this is out of the River program. I read all my lines live online. And this part here was the secret sauce that actually managed to implement and install the libraries that you're running in your local project into the container. And it depends on the RM package to do that. But once you run that, then the dependencies that you're running in your local machines are replicated inside a container. And so you have your Docker file.
Build the image.
The second thing that you do, once we have the Docker file, we're gonna bake the image. And for that, and another plug for Quada, you don't have to leave the document. If I take that comment, I can run Linux commands inside my Quada document. So it's pretty nifty. And so in this case, it's straightforward Putman build, and I give it that name. And that name matches the repo that I have on GitLab. That's the only thing that it wasn't clear to me in the documentation, but it has to match, otherwise it's gonna yell at you.
You have a container image. Now what?
At this point, you have to put the container someplace that is visible by CHTC. Typically, we do that with Docker. I don't think I think they backtrack on the license issues, but we had a little scare last year that Docker wasn't going to let institution with more than so many employees use Docker without paying a fee, and we were all freaked out. And here are two possibilities. One is, I think this is pronounced key.io. I come from Spanish, so every time I say I want to say something completely different, but I think people say it's key.io. And it's the Red Hat registry, so you can publish public container images there. And you have to make it public. CHTC at this time doesn't allow you to read private containers. The other possibility is UW-Madison's GitLab instance. And as I mentioned earlier, if you have a net ID, you can have one of those. And a couple of caveats here. You have to have your net ID account to create your GitLab account. You have to have a container associated with a GitLab repo, and they have to have the same name. If it doesn't, it's going to yell at you. And once you are in that repo, you go to the left side panel, and you do sidebar deploy packet registry. After your image is created in the previous chunk, then you need to push it to the GitLab repo. And for comparison, my laptop that is from 2019, I think, it took 4 minutes. So we're thinking about those kind of time investments, and it's simply push registry, do it with the edu, your username, and then the name of your file. Oh, because that's how long this laptop took to push the image in to GitLab. It took me 4 minutes. It's not as fast, but it's not bad either, I don't think. So the last stretch.
The last stretch, running your analysis on CHTC.
And the last part is running the analysis on CHTC. To recap, we have an RM enabled project that contains an analysis.qmd file and data associated with it, that's CSV. The Perl command stripped the code and created a file with the same name, .r. And in case you're wondering, you could run quarter documents on CHTC. I just was thinking that if it gets real computer intensive, you don't need that part rendering. You just want the computations. That's why we built a Docker file programmatically from analysis.qmd, a container image built from the Docker file with the correct version of R and all the libraries needed, a public GitLab repo. And to run the analysis, we're going to build the missing 2 files. You, of course, need your CHTC account. And so the first file that you need is the submit file. And the submit file, basically what it does, it tells the requirements for your job to run. So what do you want to run? What files and software do you need? How many standard resources do you need? CPUs, memories, and storage. Special requirements, maybe GPUs. This will not do that yet. How many jobs you want to run, and so on and so forth. And the way I approached this was I learned my lessons from the Docker file, just build it line by line. And so I created those. This is the vanilla container specs. So 1 CPU, 4 gigs of memory, 2 gigs in RAM, but you can alter those as your job needs it, right? And then I break this into what I call stanzas, right? So I give it a title, the container stanza, it tells CHTC where to find that container, and the container is the one you just push to GitLab. The executable stanza tell Condor what executable file to run, and it's going to be .sh. We haven't created it yet. The transfer stanza tells us what to do with the files that it needs. In this case, the analysis that are on the data, and what to do with the results that you're calculating. In this case, I'm telling it to use that tarball. The job stanza tells Condor how to handle all the meta files that it creates to run the job. The request stanza requests the resources needed, and the queue places the job in the queue to be run. And those lines here just actually create the .sub file. The executable file is a bash file, and we want to, it has a title, telling it that it's executable, an output folder that I give it a name. It creates the result folder. The run line is telling use R to run this R script. And I decided to compress into a table my results. For my case, I don't think I showed you what my analysis looks like, but I'll show it to you in a minute. It's very simple. It's not too complicated, but if you are running 10,000 jobs, then this line will be very helpful to you. And this creates the executable file, and here from the quarter document, you can copy directly the required files, which are .r, data, .sub, .sh, and that's where I copy it. You will need, when you get your account, it tells you what submit node you need to use. And in my case, is AP 2001 to my home directory. So I place that there. And the last step is to run conda submit dot analysis.sub. And if you want to monitor your job, especially if it's a long job, you can run that command conda watch the queue, and it monitors the queue. And the last part, if you once your job is done, you can simply run secure copy from the submit node back to your computer, and everything works great. So what I want to know is if you want, we can try running this and see how it works. You might have questions. I wonder what that looks like in real life. We can do that. And I have a couple of closing comments for you. It's the first step making this work, and it only works. I call it single submit because it attempts to do one job. So I'm now parameterizing this so you can tell it run analysis on all of these different files, which is what CHTC is great for. And it will be, I'm thinking that I'm going to create a package, and you can pass this as an argument to the package. Run this on this. It will create all the files that you need. It will move them to CHTC. And at some moment, hopefully I will get to do remote submission. So you won't even have to leave your quarter document to do all of this. If I turn it into a package, it will be as simple as multiple submit. Here's the file that you need. Here's the data. Go and get it done. So future things, but I would love for you to give me some feedback on this. This workflow assumes that the data is on my laptop, right? But if I'm working with one of those ginormous data sets that some researchers have, they might want to be using, say, Research Drive. I actually have someone who start playing with that, and it does work, but it doesn't work remotely yet. So that's something that future work. Multiple job submission, you might want to queue not one job, but 10,000 jobs. And that should be a parameter that you can pass on to the function. Remote submission, again, from here, so that you don't have to log into CHTC and run conda submit. HPC submission, none of this workflow will work on the HPC nodes yet. They have some differences, big enough so that this won't work. And finally, parameterize job specs. If you remember at the top, I have things like this is the vanilla container specs. You might want different, more memory, more CPUs, and that should be parameters that you pass on to the job.
He scrolls down to the bottom.
Oh. So my long term in the next few months is to turn this into into a package that you can, library, multiple submit kind of thing, and it will do all the hard work for you. And this was actually, I did my, I did,
He opens a small window and scrolls down the files.
I asked Copilot to design, where is it? The hex, because every art package needs to have a hex sticker. So I asked it to design a hex sticker, but I don't see it. Oh, here it is.
The hex sticker opens, a design with the text NV2 cluster.
So, okay. So hopefully when that's done, I will let you know. But at this time, this is what I have. I would love to hear what your feedback is, what comments you have, what questions you have for me. We can try running it, and it takes a while to build the image and to push it, like I said, for a minute or so. But it's neat to see the output. It's quite verbose, and it gives you a lot of ideas of how the whole thing works. So I'll if you have any questions for me, I would love to hear them. Yes. So you want to see the actual code?
The screen of code opens. He widens the window and scrolls down.
So actually, let me show you.
He narrows the window and opens a side panel of files.
So here so you get an idea. So analysis, those are gonna delete. So you start with analysis.qmd, which is this very document that you see here. And I'm just going to run the codes. So here, this loads the libraries that you need. It's not a terribly large. And what this does is this will create out of analysis QMD the .r file. If everything goes right, and it's right here, and you open that and it's just the R code. So then, and it tells you here, I created something called analysis.r. And then we're gonna come here and something important is I have RM running here and RM created this log file. And this like JSON file. And what it does is it does an explicit list of every library and package that you need to make this reproducible. And so if that is true, that exists, then
He scrolls down.
this part is going to build the Docker file. So you run this, where's my Docker file? Here on the right. How are we doing on time? Good. So this is going to build the Docker file. What are the questions?
To know if there's any Docker images that you recommend pre-build with R or pre-build for packages.
Yes, I do. I went quickly over it, but there is an open source effort to keep um, images, and it's called the Rocket Project. And if you go to the repo, that URL works, and they do a great job. You can get a tidyverse container image, or all sorts of very tailored, and they have for each major version and minor version of ours, they have a Docker, not a Docker, a Docker image there, so you can download those. I approached this. See, I'm already doing that here. So I went to Docker, and what that line does, like if I run this line, on its own.
Glue : glue open paren. From rocker / arver : open bracket. Continues.
So that line grabs the R version that I'm using and it creates this line. And with this, it knows at the Rocker project, which Docker image to use. In my case, is the one that I'm running R with. And so when I run this code chunk, it creates a Docker file.
He scrolls down the file list and selects Docker file.
And the Docker file is a text file that has, all the instruction how to bake this cookie, right? And once you have that, you can actually create the.
He scrolls down.
This will. Oh, this was the line I was super proud of. This will, inside the Docker container, rebuild your entire environment. So it's completely reproducible. And this took me a while to figure out because I was mentioning the quotation limit. Do you have a question? What's the maximum amount of data that my computer? Mhm. Well, yes, there is. And I don't know it off the top of my head. If you go to CHTC, they have, run-of-the-mill researchers. And then they have like, okay, if you really need a lot of data, then there's a slightly different workflow where you have to stage your data. But when I started talking about the place RCI, the research server infrastructure, we have a storage solution called, well, we have three now, called Research Drive, Object Storage, and Globus. And so with Research Drive, if you're a PI, principal investigator here at UW, you can get one of those accounts, and it comes with a 50 second, 25. No, 50 now, right? Yeah, I think we bumped it up. Free of charge. So you can put substantial amounts of data there. And now CHTC has a plugin where you can directly have your CHTC account see your research drive. So this workflow where I'm pushing the data from my laptop to CHTC, you might not need to do that part. Just tell it, hey, use the data that is on my research drive. And if you need more than 50, you can pay a little bit more. And the prices are super reasonable. Yes. So where was I?
He scrolls down.
Well, we can build the image, and this is what building the image. This might take a little bit longer, but
He scrolls down. He enlarges a window and scrolls up. He opens a smaller window headed Podman build.
so you can see here, building the image, it goes and reads the Docker file line by line, and it start building. Okay, it goes to Rocker, grabs the initial image, and I start adding and I start building up on it. And eventually, you end up with an image that you need to push to GitLab. And it takes a little bit. You said there were two questions.
This one might be a similar question to the last one. So how searcher to access to the cluster?
I don't know the answer to that. I think it's dependent on whether you want to, like if really I run all my code on my computer and it takes very little time. In the moment that running your code start to bite into eats into, hours or weeks, I think you might want to start moving uh, your analysis into more robust places that offer you more compute. The really neat thing about CHTC is that it gives you, without asking, 10,000 hours of compute time if you have a net ID. So in the moment that you're like, "Ugh, when is this gonna end?" In the moment you start like doing that, scoffing, yeah, consider moving your research to CHTC. Something else that is perhaps for you to know, so you can tell the researchers you work with, is that uh, well, nowadays computers can run parallel jobs, but CHTC is really good at running parallel jobs. So if you want to run 10,000 different jobs, they are a great resource to do that. Do we have any other questions online?
You said that 10,000 hours with an NID.
Yes, and if you go to search, if you go to my, just Google CHTC UW-Madison, and there's request an account, and they're super helpful. Do you have a question, Sergey? No. That's right. Did I answer your question? Right. That's probably I didn't explain myself well, but if you have intensive data, they ask you to stage your data. And what that means is they have a set of servers that are storage servers that can deal with large amounts of data. So you put your data there. And so when you go and do the other part, we say run this, then the submit server knows to talk to the stage server and look for the data that it needs to run the jobs. Alternatively, if you use Research Drive, then now the submit server can also look into Research Drive and use your data that you have storage there. So you won't have to be moving it around too much. And so we have this successfully built the container that has the analysis. And I never show you the analysis, which I meant to do that from the beginning. The analysis looked like this.
3 rows of overlays light up over the code, headed 6.8 Analysis. The Background Jobs tab is open, with Preview, Analysis.qmd.
And it was just intended to be, you can do execution, hold
He scrolls up.
on.
He opens a new folder pop-up and names the folder results-folder.
I think earlier today I deleted this, a mistake. So the analysis file looked like this. It grabs a chunk of data and it runs oh, here it is.
A slide opens.
So the analysis wasn't intended to be too complicated. Here it tells you a little bit why you should be using notebooks. Again, it's the greatest invention.
Toy Analysis.
The idea was it grabs data, loads the libraries, prepare the data, performs some calculations, and then it writes the result of the calculations and the visualization to a place. And when it does that, So what I sent to CHTC is this part here,
The right end of a flowchart.
and it creates, some tabular results and whatnot, creates some visualizations and all of that.
He returns the slide to the sidebar and goes back to the code.
And so single submit. So this created the image. And the next step, so it's very verbose, it tells you everything that it did. Here is telling you I'm grabbing all the libraries that you need, all the packages. It's very specific as to what versions. So if it's running here, it will make sure that it runs in your container. So it's very reproducible. So this is it's very verbose.
He scrolls down at high speed.
So it did all this, incredible, huh? Okay, so here you have the container, now you have to send it over to the registry, and all you do is this. Normally, it asks you for your net ID, but I have those credential cached, so it's probably just running. Yeah, it's doing that on its own.
He scrolls down.
Then here, this part's create the analysis that's up, and so let's take a look at it. It looks like this.
He opens analysis.stub.
So it's a text file that tells Conda what it needs to run and what resources it needs to run that job. Yes. Sixteen. Right. Yes. So here, this is the file that is created, but the code that creates this file, see, it has this. So if I want 10 GPUs, I'm just going to put down here 10 and then run it, and it's going to do that. And so it creates that submit file. Here creates the executable file. If I do this,
He scrolls down.
and the initial idea for this project didn't come from me, it came from Brian Buckelman, who works at the CHTC. And he told me that one of the major obstacles researchers have is getting the files into CHTC and retrieving the files, which this command accomplishes that beautifully. So if you do this, it takes a while. It asks you here for your password.
A pop-up box opens with his email address that asks for the password. He types it in, and it populates encrypted. Another pop-up box opens for a password for Duo two-factor authentication. He types one character and the box disappears.
Log you in and copy the files. Yes. Can you use SSH? Yes, you can. There is a way, and it's been a while since I run the whole thing, but they have something called master control, and it lets you cache your credentials. So, and for 2 weeks, I think. So this process is not as onerous as like every single time you have to do that, you will have to enter your credentials. They get cached. And the last step is, if you want, we can go and, so I guess this is, the proof is in the pudding. You have to go here.
A hex sticker opens with a smaller window over it.
Is you're on. Oh,
App icons pop up.
for some reason, I think my net ID and my CHTC are not the same. So I'll put myself a reminder here.
He scrolls up.
There's no way I'm gonna scroll. I think it is.
He types in the small window.
Nope. Mission denied. Okay, good. And then if I go here and I do, so if I go here and I do MLS,
He types in the small window.
we see that analysis.sub, it was uploaded. You can see it here, May 28 at 4:15. So you just move everything there. And the last part here that you need to do is do condor, I can spell. Submit. And you give it analysis.
He types condor_submit analysis.sub.
You want, hold on, what is it you want me to see? Analysis, that's, so it's the same one I opened earlier. And remember those parameters that I have at the beginning? Here they are. You don't see 10 because at the end we pushed them, right? Right, I didn't rename the file. And right now the thing is running and is it condor watch?
He types condor_watch_q.
Condor watch. So, and you see it's running on the job. It's passing on. And when everything is green, you're good to go.
Several lines of green hash marks and blue chevrons that change to equal signs appear. The blue equal signs change to green hash marks.
Oh, yes, what do they call? Obtainer builds them, but they are singularity containers. The good news, they like the singularity containers better than Podman and Docker container, but they run both. The really good news is that Singularity has, you can feed your Docker file to a Singularity tool, and it will build your Singularity container, so you don't have to really do much except add one more steps. At the end, yeah, as you can see, it ran. And to make sure that it didn't need run, we can come here.
He scrolls down the code and text.
The last step is we run that, and we're gonna try to get those results back into our laptop. Diamond? No. Diamond is another solution. I know, is this related to Pelican? Oh, okay. Yes, I don't know much about this, but so let's see here. We have simple submit, and the results are somewhere here. Oh, here it is. So the analysis result, the tar, let's take a look at that.
A hex sticker opens with a small window on top of it that includes the lines of green hash marks. The window moves away, then the sticker.
Sorry.
The window returns.
Analysis result tar. So that's the file that it got back from CHTC to the 220. And if we open that, we see in there our a plot and the CSV file that it was created with all the calculations that we ask them to run for us. And so if you were to try this today, all you will need to do is go to the repo that you guys shared, right? That they share with you, they are online, and you can put your own analysis of QMD or change the name and your own data.csv and have yourself a CHTC field day. Well, thank you for your attention. If you have any questions, please let me know. If you have feedback, I would love to hear that. And I appreciate your attention. Mm-hmm. Yes. You want to know where I'm saving it? Yes.
He returns to the code.
So when okay, so here it is. So this is inside of our project, right? So it's relative to the project. So analysis, the R data.csv, analysis.sub, and analysis.sh, and it's gonna copy it to my home directory. Right, and when I read it back, I read it from my home directory, the one that I knew my script was going to generate. If you try to write, you probably have a CHTC. So if I were trying to write to home.autos2, it's gonna yell at me. Yes, it will not work right now. No, you have to do some magic to let CHTC see your research drive before it runs. Right, that's exactly right. Do you have any other questions, comments? No? Well, thank you for your time again. I appreciate it.